Of you. So myself, Dr. Sougata. Actually, this work was done by Priyabrata Biswal. He was one of my PhD student. He just graduated. He so told that he will come, but due to some urgent work, he didn't come. So that's why I have to present it. So this paper actually accepted in the option B, that is the census letter, and that actually I am presenting here. So it is basically based on the circular hole in a Piezo. We all know the Piezo harvester. Okay? Now, if you change any dimensional changes in the Piezo harvester, so then it will change the, you can say, sensitivity or the output of the Piezo harvester. So it is basically based on this one. So in this contents, we have the introduction, literature, survey, and whatever things are there. So now, so if we look at any energy harvesting system and self-power system, our motive is to design a self-power system where you have a sensor node. If you want to drive a sensor, then it requires a power supply. Right? It can be battery, or it can be, you can say, some other sources of power. So whether we can to generate the power, and that power can be used to drive that particular sensor node. So here, the different kind of, you can say, the harvesting of the power energy can be harvested. You can have, mostly we have considered the vibration energy. Now this vibration energy, you can have different, you can say, vibration sources. You can harvest the energy, and those energy you can use to drive the sensors. Here we are mostly concentrating on the accelerometers, whether we can, you can say, drive the accelerometers or not. Now, if you look at the typical piezoelectric energy harvester, which is basically called PEH, so the short term, there you can have this, you can say, a power conditioning circuit is there, and the sensor is basically a cantilever beam kind of thing. It can be bimorph, it can be unimorph also. And then if you put some pressure or force, because of the deformation or the stress strain profile, the charge will be generated, and that charge can be converted to equivalent voltage by using the power conditioning circuit. So there are many, you can say, researchers, they are working on these piezo harvesters, and there are different materials are also there. The macro scale means in the large dimension wise, people are doing also. Micro scale also people are doing, but the major problem with the piezo harvester is that the harvested energy is very less. So, so if you look at the literature survey, there are, you can say, these powers are basically 1.3 milliwatt and 0.46 milliwatt. Those are basically for the macro scale harvester, not the micro scale harvesters. So these are the different circuits. For the interfacing circuits, you can have SSHI circuit, normal, you can say, rectifier based, you can say, harvesting the power conditioning circuits are there. And the improved, that synchronous switch based harvester on inductor SSHI based circuits, there are some, you can have the improved SSHI circuits are there. So if you look at any self-powered system, so there will be one energy sources, and that energy sources will be, there will be a power conditioning circuit, and that generated power will be able to drive a particular sensor. So the main objective of this work is that we have so worked on the piezo energy harvesters. We have changed the dimension, and there, by changing the dimension of that, we have improved the power efficiency of that particular energy harvester. And with that energy, we have designed a power conditioning circuit, and with those powers, we drive the sensor node. It is only the accelerometers we have done. So now here we have done, you have seen that this hole is there. So this is the normal energy harvester, piezo harvester, and within that piezo harvester, one hole is being intentionally created. If you create the hole, and we have studied the different simulations that based on the hole, you can say, diameter, position of the hole. So based on that, the resonant frequency of the piezo also changes, and also the, you can say, the voltage sensitivity and the charge sensitivity is also changes, right? So based on that, we have made the different circuits for the harvester, you can say, energy, how much energy it can be harvested. So you can see here the conventional piezo harvester, it is generating with this circuit can have. So this is the basic block diagram of how we are generating, or the piezo is generating the energy or the voltage. And then we can have the diode circuit. Then we have used a normal regulator HT7333, that is an LDO based regulator, and then that is being used to drive the load. We here the load we have used a simple register also we have used. We have used an ADXL 335, that is an accelerometer that we have also used. So if you look at the power generation, average power generation of, you can say, the conventional piezo harvester, it is 56 microwatt power generated. But if we make the changes in the dimension, that is the circular hole which is being created within the piezo harvester, that is creating almost more than double the power whatever is being generated, that has been increased. Now, what we have done, so there are the people are working on the power conditioning circuits. Now, power conditioning circuit, the simple one is the diode, the rectifier. You can say 4 diode full wave rectifier is there, but there is the rectifier based circuit. So there are some losses are there. Fine. So to improve the performance of the power based circuit, the researchers have, you can say, proposed this SSHI circuit, SPSSHI circuit. We have implemented all the standard the SSHI circuit best circuit configurations, and then we have used a regulator, low dropout regulator, which is HT7333 to drive the load. So the basic purpose of HT7333 is basically to provide a stable voltage, which is either 1.8, we can go for 1.8 volt, we can go for 3.3 volt also. So here, as we have seen, if we use the SSHI based, so this SPSS self-powered SSHI based configuration with HT333, here you can see the conventional pH, it can give 85 microwatt, but the proposed hole based one, it can give almost, it is less than double, but it is almost double the power. You can increase the power. So again, we have gone for the improved SPSSI based circuits. Here also you can see the maximum power, whatever average power we are generating here, 170 microwatt of power we are generating here. Now we have all the laboratory based experimental setup we have done. We have used a, you can say, vibration based setup with the subwoofer system. So we can drive this subwoofer, we can create the vibrations, and then we can measure all the power things. We have measured it with all the multimeters and the setup. And based on that, we have whatever the result we have shown it before, that 170 microwatt or 89, based on all these experimental results we have created. Now in the right side, you can see the top figure. So it is the piezo is the middle one. And then here you see the two setup, one with hole and another is the standard without hole. So the without hole based circuit, whatever the power, as I showed you, it is around 89 microwatt, but with hole we can go up to the power consumption, the power whatever being generated, 170 microwatt of power, we can do it. So this is the comparison of the different circuit configuration. One is SCH, that is the standard harvester, and then we can go for the IESP SSHI or the SPSSHI. So all three configurations we can have the improvement, the with hole and without hole, and whatever the percentage of variation. And we have seen that with, if you incorporate the hole, and then the power whatever being generated, it is improved. Now what we have done, so that this is the input of the power, whatever being generated by the harvester. Then what we have done, we have included, so here you can see, so here we have included one ADXL, you can say we are, whatever the power we are generating, that we used to drive the ADXL 335, you can say, accelerometer. And whatever the being power generated, it is can drive the ADXL 335 accelerometer with the whatever the power is being generated by the piezo harvester. Now from this, what we have done, so this complete system, we have built one complete circuit. So this is the middle one, is the complete cell power system. Here the accelerometer is there. And then this complete system, we have made a T setup, a T-type structure, and then we have mounted on the scooter wheel to check that when it rotates, this you can say wheel rotates, then it will the piezo harvester will generate the energy, the power, and the accelerometer, which is being mounted on this PCB we have built it. We have designed and fabricated, and then everything, these power conditioning circuits are being there. So all this we have done in with the discrete components. And then if you rotate the wheel, the based on if you move the scooter, so then it will be rotated, and based on the piezo harvester, the energy will be harvested, and it will drive the accelerometer, which is mounted on, you can say, on the PCB itself. So from this harvested energy or the accelerometer data, what we can do the vibration analysis. We can acquire, we can store. And here you see we are running the scooter for a particular speed. And then you can see whatever if you do the F50 of this, you can see the frequency is 2. If the frequency means that depending on the speed and the wheel diameter, the frequency will depend. So from here, what we can say that here we have just proved a concept that whatever the energy is being generated by the piezo harvester, that will be able to drive a particular sensor. Though the piezo harvester, the energy or the power generation is less, but we can integrate multiple number of piezo harvester to get more energy and the more power, and we can drive a particular sensor node. And all these we have done with the discrete components and with a larger board, but we can also minimize everything, the component, we can minimize it, and we can have a smaller board for this. So in conclusion, it is basically a concept, the self-powered sensor system. It is being proposed, it is being validated. So the energy, you can say whatever being generated, the efficiency or the improvement is being done by incorporating the circular hole within the piezo structure. And we have seen that if we do those dimensional changes, the piezo can generate more power compared to the standard, you can say, piezo harvester. And then whatever the power we have conditioned, and then we have to driven, or we have drived a, you can say, accelerometer, the ADXL 335 accelerometer we have driven. And we have mounted it on a vehicle, and we have tested it really. We have collected the data, and we have seen that it can drive an accelerometer, whatever the energy is being generated by the piezo, it can drive the accelerometer circuit. So this is like a concept of self-powered sensor system, where vibration will be the energy source, and any other sensor, not only the accelerometer, any other sensors can be integrated. And nowadays we know that all microsensors are coming it up, and there the power consumption is less, not in the milliwatt level, it is in the microwatt level. Fine. For those, we can use the vibration sources. Everywhere we have the vibration sources. So in those cases, we can use this piezo harvester to drive a sensor node or a sensor. So that is the basic the purpose of this work. These are the references, and thank you.